Hi all, just letting you know that this is a SnakeDemo video. We're doing some uh, programming work that involves array lists and a few interesting concepts to develop the Snake game. Now, our end product should look something like this, where I have a snake and I'll be able to move it. I've set the frame rate low here, and eventually I'll be able to actually collect an apple or end the game by losing. Now, it's easier if I'm moving faster. Now, our idea is that we want to start with grid size. We want to start with a setup function, which sets the size of the canvas, and a draw function, which ends up being a loop. We'll also want to add a key pressed function. And we'll define our movement really simply. If our key is up, we want to have something to do. If our key code is down, we'll do something else. And likewise, we'll do the same for left and right. Okay, and we'll come back to that later. This defines our key behavior. Our draw method will be filled up in a moment, but this is where our game logic happens. And in general, we want to have an if statement that says whether we play or lose. To get the game started, one thing I might do is check on a mouse click. So I could do a Boolean playing equals false. So we can say something like if playing, we want to play the game, else maybe we want to put some text to the screen. With color white. And size let's say size 50. And we'll see how this looks. In general, we'll start with our text there. Maybe we'll reduce the size to say 20. And we'll start right there. Great. Now the way we activate this is we just say mouse clicked. We'll set playing equal to not playing, so we'll just switch the value. So one thing we can do is we can say click to start, we click, that goes away, we click, and it goes back. So it's almost like a pause button. Now, let's get building the game. Things that I want to include are maybe a fruit, and I might also want to include a snake. Again, this game is a little biblical. That's fine. We do want to eat from the tree of knowledge here, in the sense of programming knowledge. So the fruit is going to be easiest to define. So for a fruit, we want a few different methods. First, we want a constructor. We want a method to show our fruit on the screen. And then we maybe want to respawn the fruit in a new location after it's been eaten. So in this case, for show, we know we want to maybe have, let's say we have a square, because we're a little boring today. So we'll fill with color. Let's make it a blueberry. And it'll be a rectangle at some location with some width and some height. Now this is going to take a little bit of time to define. First of all, because we want to know that we have some x, y, width, and height value. So we'll start out saying float x, y, width, and height. And we have to define those in the constructor. So we could always say x will start out at some position. Let's set it to a random position. And we'll start out by saying let's set it anywhere from 0 to the width. And y will be random 0 to the height. But we also want to increase or have the width of the fruit itself. So width maybe 10 and height maybe 10, make it a square, and we'll subtract 10 from each of these. And in that way, I can have a fruit in this game. I'll instantiate it. And I will show the fruit. It won't move or anything, but let's see if we have the fruit playing on the screen. We click the screen and we see the fruit there. If I want to run again, make sure it's randomly generated. I click and the fruit is in a different place. So that looks all well and good until you realize that with Snake, what I end up having, and I'll make this a slightly faster frame rate, what I end up having is a situation where I'm following a grid. I line up exactly with the fruit as I eat. So I've set up a grid value here, grid size, to know how many spaces, how many columns my grid has, and how many rows my grid has. And fruit's going to want this information. So I'm going to pass in grid size here so that I can use it when I make my fruit, so that it lines up on the grid. That means I need to change my constructor. And I'll just have some value grid there that then I'll use to define this sort of fruit object. The first thing that we do is we want to say the width of the fruit. It should line up exactly in a column and exactly in a row. So it should be the entire width of the screen divided by the number of spaces or columns in the grid. So that would be the width over the grid. Likewise, the height will follow the same way. I really recommend you do the math on this on paper, try to do it on some graph paper, and see how these values come about. Finally, we also want to spawn in a grid location. So one way to make sure that we do this is to say that I want to spawn from 0 to grid -1, so that I don't spawn and draw my image off the screen. And whatever that value is, first I want to int cast it, and then I want to multiply it by what? Well, we'll have a look at that in just a moment. Additionally, I'll do the same here. And I want to multiply to generate a random number from grid -1. And the whole idea here is I'm trying to line up on the grid. So I'm putting myself in a specific column. And ultimately, how far over I am depends on the width of my object. So in this case, let's say I multiply by width and I multiply by height. So if I were to run this again, I now appear here. Now, if I wanted to make a bunch of these and see how they stack up, I could always make a fruit array and make a new fruit array of size grid, and then, or grid size. Then I want to say for int I equals 0, I is less than f dot length, I plus plus, f equals new fruit grid size, and then I want to sort of set the values here. F position I want to set the value of x to be, say, I times grid size, or times, yeah, let's say I times grid size, then f position I, well, we'll have it here. Equals 0, let's say. And what we want to do this is times 10. So if we run this and we do a for each, we should see something interesting appear on screen when I click. Okay, I did not. I believe that should do the job. Yeah, so we'll notice that we have exactly the right amount. If I have a grid size of 25, I have 5, 10, 15, 20, 25 different pieces, and they're all stacked up perfectly. So going back to what we had before, you can retroactively skip that section if it was confusing. That the whole point of that is to show that we are sort of lining up on a grid. So here we go, and instead of having a fruit array, we just have a single fruit. And here is the idea. We also want to respawn in the case that we get eaten, and the way we do that is we just generate a new x and y value. And in this case, we can take the so we don't have grid here. Let's take advantage of global variables. Sort of cheat our way into that. Grid size still exists from the other files, so we can use it here. Otherwise, I'd probably want to store the actual size of the grid in another variable here. So our fruit class is all done. Again, if I run this, I'll get a fruit lining up on the grid in random positions. Now for our snake class, the first thing is to see if we can make a snake that's a different color. In fact, I'll copy this code to do so. And instead of fruit, we'll say snake. And we'll also line it up with a grid. And instead of respawn, we'll have a few different methods here. We're going to start with a show method. And instead of being blue, we'll have a red snake. In fact, we'll have a magenta snake. Very interesting snake. And instead of signing up for a random location, we can say that we want to be on a grid location. So grid over 2 times W. And let's make this an int. And we'll do the same thing for height. So we'll always start in the center of the screen. So if I were to make this snake, we want to show our snake, and we'll run this. And we'll get our magenta right in the center of the screen, and our blueberry somewhere else. Now, as we're writing this, what does the snake want to do? Well, we want to be able to move the snake. And in general, we want to move by adding an x velocity to our x value and a y velocity to our y value every frame. Except in our case, we don't have those defined. Now, there are a couple ways to go about defining these values. The first is to do something like this. Have those up there. And then when we want to set those values by pressing keys, we have something that's very, very strict. With snake, I only want to be able to move either up, down, left, or right. I don't want to be able to move diagonal. So when I start moving one way, I want to immediately cut it in the other directions, or direction, in a two-dimensional case. So I'll make something called set velocity, which takes in two integers. And we'll call them A and B. And we'll say that Vx equals A and Vy equals B. And when we want to move, what we can say is if I want to move up, I s.set velocity, I set the velocity of the snake to have a 0 in the x direction and a -1 in the y direction. Likewise, I do the same for down. I just set this to a 1. For left, I set this to -1. And then for right, I set it to 1. Now, all of this is not strictly necessary, but it helps keep our ideas organized in such a way that I'm guaranteed to know that I have my x value be 0 and my y value be -1. I can see very clearly that I'm only moving in a certain direction. So, how does this look? Well, if I run the game, and I click and I press left, nothing happens. And the reason for that is because I haven't called s.move. Motion isn't happening. So we run again. I press left, and I start moving left. I press down, and I start moving down. I press right, I start moving right. But you'll notice there's a problem. And that problem is that I don't go completely exactly onto the square. And so that means that in our move method, we need to rectify this by aligning with the grid, which is one of the reasons I've chosen that one value, that very clear value for my motion. So let's see what we can do here. I go to Snake, and I say I want to multiply my Vx by my grid size, or by my width, and I want to multiply my Vy by my height. And the reason for that is I want to be able to say that I am, in fact, aligning exactly with the grid each step I make. But the problem is that means I'm going to be moving fast. But it does look like I am aligning with the grid. So one way to fix this, temporary way, is to, I could always limit the size of this speed, or I could limit my frame rate, which is really convenient, to 20. So now we can see pretty clearly what's going to happen. Now, one thing that we might want to do is have something where I go off the edge of the screen. If I go off the edge of the screen, I run back to the beginning of the screen. One way I can do that is I can say if x is less than 0, x equals width minus w. If x is greater than width, x equals 0. If y is less than 0, y equals height minus h. If y is greater than height, y is equal to 0. And this will allow us to go around and around and around. And so in this manner, I can go off the screen and not die. Now, another way you could do this is you could say that you won't die whenever you go off the screen. Now, that's up to you if you want that type of game. For us, we'll keep it like this. Now, you'll notice I'm landing exactly over the fruit and nothing's happening, so now let's make that happen. We'll make a method called eat. And we'll pass in fruit f. Food, let's call it. If we are in the same position as the food, and we're guaranteed to be able to match up exactly because we are on a grid, so I don't need any fancy if statements. Well, what do I want to do? I want to respawn the food, and that's going to be it for now. In the future, the next step, the final step, is building my tail. So if I run this right now, let's see. I haven't actually called eat yet, so what we'll have to do is s.eat. We'll run this again. Eat F. We'll eat the fruit. Oh no. There we go. Respawned. You might argue that we're almost done. We still have a hard part to go, but I'd argue that playing the game, in my case at least, is a little harder. Now there's still a couple bugs that you might want to address on your own, but in terms of getting some game, you can always turn this into a game on its own where you have a timer, and however many you collect in a certain amount of time is your score, etc. Now let's go about building this snake. So it's important to notice that with our snake, we have the position of the head of the snake. But we also want to be able to build a tail. So in our case, a tail is going to be helpful to have some sort of array list. And here I'm going to introduce the class pVector, which represents a vector quantity with x, y, and z values, has methods for addition, subtraction, multiplication, division in vector values, with vector values. And what we're going to do is we're going to have a tail that is an array list of pVector objects. We'll initialize it here or instantiate it. And it is going to be as such. Now, what do we want to do? Every time we eat, we want to add to the tail. Where do we want to add? To the front of the so we can add to the front of the tail, and we'll add the current x position and y position. Now the way I do this is I call new pVector and I'll say x, y. And we also want to show the tail. So the way we show the tail is by saying, let's say we want to fill with a different color for the tail. Let's say a more muted magenta. And for each pVector p in the tail, I want to make a rectangle with p.x, p.y, the width and the height, which should be the same. And if I were to do this, well, this might fly in terms of showing something, but ultimately it's going to leave sort of droppings wherever we ate food. It's not going to follow us. So if I were to run this, I should get something very similar. Now let's see what happens if I eat the food. I left a little bit of myself behind. Now, how do I get these pieces to follow me? This is also, by the way, a fascinating game that you could make. You could always build off of things like this and make your own versions, you know, make them viral, sell them on the App Store, just like that Brick Breaker game. So maybe the objective of this game would be don't hit your previous objects. And when you do, you finally you die. But in our cases, we want to see first the tail move with us, and second, we want to say that if we collide with the tail, we die. So those are the last two remaining pieces. They're actually not so hard. We can say that if tail dot size is greater than 0, if our tail exists, we want to say that the tail should add to 0 a new value but we should remove from the back the last position, so that we build up from the front, we remove from the back, so we maintain the size. We added one, we removed one, we're the same size. We've just shifted everything down, and we've added something to the front near the head. In fact, the old head position. Now, this has to be up here, because we update the head position after we move the tail forward. So let's see what this looks like. Now we have a tail moving with us. And it even grows. Now I guess the idea would be, I don't want to run into myself. Now, the better way would be not to run into the wall either. But eventually, I want to get to a point where worst comes to worst, I would have to possibly run into myself. So you'll notice that I'm running into myself a little bit here. And you don't want to do that. You want to have some situation where you are, in fact, independent. And if you do collide, you want to lose. The way we're going to end up doing that is we're going to say, so there I ran into myself. What we're going to say is that we want to check for a collision. And we're going to return true if we collided and false otherwise. And the way we check for a collision is very similar to how we check against the food. For each p vector, p in the tail, if p dot x is equal to x and p dot y is equal to y, meaning where the tail position and the head position are in the same place, we'll return true. Otherwise, we'll return false. And what we want to say here is, if playing, and each loop will say collide. If playing and state, if playing is true and state is false, then we want to play the game. Else, if state is true, we'll show an end screen with the score. Where the score is equal to the length of the tail. Otherwise, we'll just be looking at our stop screen. So let's see how this works. And we didn't call it collide, we called it collision. So if we collided at each round. We want to check that and see what happens. So there's a little inefficiency here, but this should sort of work. Okay, let's run that again, see if there's a bug there. So this has to happen after we move. So we'll say that we set state is false to start, and then after we move, after we eat, we will check to see if we have a collision. See if that change helps us out. And that is in fact correct. Now if I try going backwards, then you'll notice that I run into myself and I lose. This will be the same if I collide in any other way. Now, you can expand this game as much as you want, but this is my simple version, and it's a pretty long video, so we'll call that the end. Have a great night.